Waves. Alright, that's what we're going to be discussing today. Questions we're going to be answering. First one here. What does a wave carry? Well, a wave is a disturbance that carries energy through matter or space. So the main thing I want you to get from here is that a wave carries energy. Again, a wave carries energy. The other thing is that there's a difference between wave motion and object motion. In this problem here, they're showing us that the wave is going from left to right by this arrow, and here they're telling us that there's this object motion. The leaf is going to go up and it's going to go down. So this wave is going one direction and objects go the other direction. This is evident on a lake. If you're on a lake and a wave comes at you, the wave might move from one side of the lake to the other, but your boat's simply going to go up and down. Most waves travel through a medium. Alright, a medium is a physical phenomena or environment in which phenomena occur. There we go, a physical environment. There's a specific type of wave, such as mechanical waves. This is a wave that requires a medium through which to travel. Examples are sound waves, water waves. These require a medium. Alright, these right here require a medium. Mechanical waves require a medium. Okay, just the opposite now of mechanical waves are electromagnetic waves. These are waves that do not require a medium. These type of waves do not require a medium. Examples of these are light waves, radio waves. Electromagnetic waves can travel through space. In outer space, there is nothing. There is no medium. So it's these type of waves that can travel through outer space. Okay, again, energy and waves. Waves transfer energy. A tsunami is an example of a really big wave that's transferring energy. All right, so tsunamis carry energy. And what we're going to talk about today is out in deep water. All right, out in deep water, what happens here then is that it's going really fast. A tsunami is going really fast. It's not very tall, but it's got lots of speed. The velocity is high. So it has kinetic energy up the wazoo, very little potential energy. Alright, so it has lots of kinetic energy because it's velocity. Once it gets up into shallower water, it slows down, so it loses kinetic energy. But energy can't be destroyed, so what happens? It gains potential energy. Why? Because it gains height. Alright, the wave gains height. It slows down, but it gains lots of height. Out here in the ocean, it might be going as fast as 400 miles per hour. Up here, it's going to slow way down, but it's going to gain a lot of height. Energy may spread out as waves travel. And what this is really making a reference to is, think about if you drop a rock in the water. All right, you drop a rock in the water, and right here now you have this wave, and it's really high. But then as this wave starts to go out, it starts to dissipate. Right, the wave gets lower. Alright, it's becoming less concentrated. So up here close, you had lots of energy, and as you can see, the wave starts to dissipate. It becomes less and less. If I look at this from the side, when you first drop the rock, you might have a pretty big wave. About a meter away, you have a little wave, and then another meter away you have a much smaller wave. So the wave is dissipating. It's not that it has less energy, it's that it's got a bigger area. When you first drop it, there's 100 joules in just that area, so it's really concentrated. I'm just using 100 joules as a number. Then the energy is spread out over this area, so it's becoming less concentrated. Then the energy is spread out over a bigger area, and it becomes less and less concentrated, till finally you've got this 100 joules of energy, but it's spread out over a much larger area. Okay, vibrations and waves. Most waves are caused by vibrating objects. When you sing, your vocal cords vibrate. Electromagnetic waves, waves that go through outer space, are charged particles. Mechanical waves, it's the medium that's vibrating. The last type of waves we're going to talk about today is transverse and longitudinal. All right, transverse and longitudinal. Well, what's the difference between them? Transverse wave is a wave in which particles of the medium move perpendicular to the direction of the wave that it's traveling. This is like a water wave in the boat. Here's the water wave and the boat. So the wave is going in that direction, and our boat is going to be going up and down. Notice that they're perpendicular to each other. They make right angles. The other one is a longitudinal wave. This would be like a slinky, all right? A wave in which the particles in the medium vibrate parallel to the direction of the motion. So if you think about stretching a slinky, and if you let go of it, the wave moves, and then the slinky, the spring, moves in that same direction. Transverse and longitudinal waves. All right, well, here's what they look like. In the top one, we've got some descriptors here. The crest is the highest point. The trough is the lowest point. Compressions, this is where the wave, this is on a longitudinal wave, this is where the waves have been compressed together. And the rarefaction is really the only hard one to remember, and that's where the area, the wave, or the spring, for example, or the wave has been stretched apart. Alright, got 3 questions here for you. What does a wave carry? How are waves generated? And what is the difference between a transverse wave and a longitudinal wave? Well, you go ahead and answer those, and I'll catch you on the flip side.